Hello everyone, a very good afternoon to all of you. I am Priyanshi welcoming you all on behalf of Solar Kocha and Forestry Group to the second day of Eastern Africa Solar Week. Hope you had a good time in networking with your peers today. We'll have those networking sessions after the end of the panel discussion. Now it's time to start with today's conference, but before that, I take the pleasure to thank our platinum partner, Jinko Solar, for extending their immense support to organize this event. I request my team to please play the sponsor videos. Thank you, team, for playing the videos. Here, I would like to make a small announcement. Attendees can post their questions in the Q&A box. Our panelists will answer those questions at the end of the panel discussion. Now, without any further delay, let's begin with our day two of Eastern Africa Solar Week with an exciting and insightful panel discussion on rooftop solar, future advancements in project models, financing, and technology. And in the night panel, we have with us Mr. Samir from who is an independent engineer, Mr. Julius from Area Finergy, Mr. Atharva from Lean Energy Solution, and Mr. Justice from Ecoligo. The session will be led by Samir sir. Now I welcome all the panelists on the screen and handing it over to Samir sir. Thank you so much. Please take it over.
Thank you very much, Priyanshi, for this fantastic effort. And big thanks to Solar Quarter for their continuous work in making the solar PV more accessible and to all people around the world. And big thanks to the Jinko, our platinum partner in providing the world with high quality solar PV modules so we can enjoy clean energy and make the world a better place. I'm very happy today to be part of this esteemed panel to discuss the solar PV in East Africa. I'd like to start by introducing Mr. Julius. Mr. Julius has a telecommunication and engineering degree with 4 years experience in the solar PV industry, and he is currently working as site manager in the project department at Area Fin Energy. And I asked him what is the meaning of Fin Energy, and he told me that they do both financing and they do the energy project. Mr. Julius, are you with us?
Yes, I can hear you loud and clear. Thank
Excellent.
you very much, Samir, for that wonderful introduction.
I
Yes,
like
my name is
yes,
stated above, Julius Gitonga. I work at Area Finergy. We are an engineering company focused on renewable energy, specifically solar. We do finance solar systems in the commercial and industrial sector, and we also build the systems ourselves. Thank you.
excellent, excellent. I have a few questions for you, Julius. The first question is, what is the most widely used PV module technology, and what technological advancement will be seen this year? Over to you.
Ye- Yeah, thank you for that. Right now, the most widely used technology, module technology, is monocrystalline, I believe, and we have seen an improvement in the system's efficiency over the years uh, due to adoption of the monocrystalline technology by the relevant companies. And we've seen improvements of both in module sizes and efficiency throughout the years. And I think the most notable change that we noticed very recently is the introduction of the half cell technology, which reduced the losses, the power losses in the modules, thereby eventually increasing the solar module efficiencies. And I think what we are about to see this year is bigger panels. Yeah. Currently, I think the biggest we have in Kenya, we have used 550 modules, 550 watts. But I have seen Jinko, they have a 620. And some other companies are also claiming to have modules that can produce as much as 700. So I think there is towards 1 kilowatt module is on. Yeah. Thank you. Samir, did that answer your question?
Excellent, excellent. So we are going to see bigger size modules and half cut monocrystalline. Uh, One more question about the inverted technology. How is it evolving, and is it helping in the uptake of the solar PV in the region?
Yeah, yeah. I mean, I think it's helping a lot and it's evolving. There is the most notable key trend in this solar segment is has been the increased focus on balance of systems to maintain high returns on investment. In about a decade, the maximum central inverter has gone from 100 kilowatts to about 5 megawatts. The string inverters as well has increased from 10 to 15 kilowatts to all the way to around 100 kilowatts. We have seen some inverters being able to produce about 180, 185. So I think
Hmm.
uh, the development in the inverter technology is encouraging to developers, bringing down the costs of installation, and operation and maintenance costs are also being brought down as well. So what we have seen is that the new inverter systems are equipped with grid features that accommodate smart grids, and these inverters are modifying themselves into enhanced energy management centers with the use of sensors, temperature sensors, uh, radiation sensors, and so on. So these the string inverters notably has been adopted even by utilities because they reduce the downtime of plants. You can imagine where you have a central inverter and you have a problem or an error with that inverter, the whole plant goes down. Whereas with a string inverter, you just need to identify the string that is problematic, disconnect it, and uh, solar continues to, the plant continues to operate. I remember I saw a post last week whereby in Ukraine, a bomb landed on solar. And then within a few days, those guys were able to isolate the sections that were affected, and the plant was up and running like nothing ever happened. So, yeah.
Definitely very exciting. One more question, if you allow me, about the solar PV with storage and acting as a hybrid. So, hybrid systems with storage. Um, are we seeing this in Kenya and East Africa? And what are the advantages of using them?
Uh, yes. We actually, one of our core business at Area Affinity is stabilization of power, and we are doing this with energy storage systems, specifically lithium-ion batteries. And to be honest, right now is still a little bit expensive to run factories on batteries, but we have found an efficient way of utilizing the batteries by optimizing the solar, whereby where you have an excess, since we don't have a net metering yet, and where in cases where the solar has been a little bit oversized, the excess power that is generated is stored in the battery, and then whenever the loads are higher than the solar being produced, that power is drawn from the battery. So we have seen some improvements in our systems whereby uh, we have installed such solutions, and this has improved the overall efficiency of the solar system. Another way that we use the batteries is that we offer continuity in production, because in cases where we have outages, you find clients complaining that they have to maybe discard the entire materials which were in the production line due to the interruption of power, and then start all over again, incur costs of recycling and all that. So we use batteries ourselves to offer seamless transition from the grid to generator and back to the grid. And we've seen significant savings in terms of offering that seamless transition from uh, grid to genset and back. So yes, I mean factories and malls are definitely adopting energy storage systems in combination with generators.
Thank you very much, Julius, for these amazing answers, and I'm sure we will come back to you with a few more questions after we hear from our esteemed panelists. Uh, Ar-
Awesome,
Atarva,
pleasure.
thank you. Atarva, are you with us?
Yes, yes, I'm here.
Excellent. Our next speaker is Mr. Atharva. He has a bachelor in electrical and electronic engineering from the University of Bath in the UK. He founded the solar EPC and financing division under the umbrella of Lean Energy Solutions Limited. He completed numerous solar projects in Kenya, and I'm going to ask him to say a few more words
Yeah.
about himself and the company.
Yeah, great. Thank you. Thank you so much for the introduction. My name is Atarva. I'm one of the directors at Lean Energy Solutions. Lean Energy Solutions is basically a renewable energy company based in Kenya. It was founded in 2006. We manufacture briquettes from biomass, so that is our major business that since 2006, and we are into boiler conversions as well. So we replace HF4 or diesel-fired boilers with biomass-fired boilers, and we sell steam to clients. So we're basically just an energy service provider, and with this. Compared to the HF4 and diesel, we actually offer pretty significant savings to the client for their steam consumption. Summer, you're on mute if you're saying something. Yeah. Okay. And then in 2019 is when we went into solar power. So that's when we started the solar division under the umbrella of Lean Energy Solutions. Since then, we've done about 3 megawatts of solar EPC and financing projects. And then we currently have a pipeline of about 30 megawatts, which we aim to complete by 2024. And so, yeah, that's just an introduction about the company. So, Summer, if you have any questions, yeah.
Yes, thank you very much, Atharva, for this amazing performance so far. I'm sure that you will do many amazing projects in the future. My first question is about the evaluation of centralized versus decentralized solar power options in the region for commercial and industrial projects and residential customers. Can you tell us a little bit about that? Over to you.
Yeah. So basically, I'm going to mainly speak about Kenya, Nairobi, Kenya, because I'm based over here. So in Kenya, we have centralized power. So where we only have basically one utility provider, which is Kenya Power. And all the people here, we know how Kenya Power operate. And so, yeah. we are heading towards more decentralized power because we are seeing a lot of foreign investment in mini grids and microgrids, but I feel like that sector is still in the very early stages because you are essentially setting up one of the most expensive types of power plants with storage and very complicated systems in the rural areas where you have a lot of low income earners who are not able to pay as much for power. But there has been a lot of investments in that sector in Kenya because, like in our conversation before, only about 60% of Kenya is actually electrified, and the rest actually don't have access to electricity. So that's where the 40%, there is a huge scope for mini grids and microgrids to come in to basically electrify these regions. But I feel like on its own, this the mini grids and microgrid sector, it can't flourish on its own because it needs a lot of grant funding, which we do get from certain investors, but it's not. I feel like the market is not yet mature where private companies can set up independently without grants because the financials don't quite make sense yet. But one thing we're heading towards, which as a company and as Lean Energy, we're super excited about, is net metering. So net metering, EPRA, which is the Energy and Petroleum Regulatory Authority in Kenya, they have come up with draft regulations for net metering in Kenya. So we're hoping maybe in the next 6 months to hopefully 1 year, we do have net metering taking in place. And basically, the gist of those regulations are Kenya Power. Essentially, any power you supply back to the grid, Kenya Power will give you credits worth of 60% of the power that you basically export to the grid, because so that's how they are going to be working towards it, which is really exciting because for developers and finances such as us, one of the problems that we do face in the industry is that we set up these massive solar plants like 200 300 kilowatts, but then the consumption from the clients can be fairly poor. And most of the PPAs are consumption-based PPAs because of the competition here in Kenya. So you have consumption-based PPAs and clients want the biggest of systems, but then when it comes down to the daily consumption, their daily consumption is pretty poor, and they're not able to consume to the maximum size of the system. So this will really help developers. And after this net metering, I see a lot of foreign investors, a lot of investment will be coming in because now you can set up plans, and if your consumption is poor, you can still sell back to the grid and get those credits as a developer, which is a huge advantage to developers such as us. So I see definitely lots and lots of potential, and I feel like because solar in Kenya is heavily underutilized, so from our grid only 2% of the power comes from solar and the rest is from geothermal. We have a few thermal plants and wind, but only 2% come from solar. So I feel like we can really overcome this by decentralizing, by having net metering coming in and decentralizing the entire market. So we don't specifically have to set up a big utility projects like 40 megawatts, 100 megawatts of solar projects, but we can simply decentralize and have net metering take place, and then get significant savings from that for clients, for developers, and it will be a win-win situation. So I am pretty excited, and I see a lot of potential for this in the next coming years, and it's definitely a good place to be for developers. So I see a lot of foreign investment and foreign investors coming in as well, which is exciting.
Excellent, excellent. You talked about the rooftops, and what are the top challenges faced by developers in terms of installing the rooftops and getting permits, sourcing the funds, and connecting to grid? Over to you.
Yeah. Yeah, so I think there are, as any market, there are quite a few challenges faced by both EPC companies and developers in this region. But one of the definitely the time for permits is one of the main challenges that we do face, because for every solar plant, you're required to have a generation license, especially if you're a developer and you've set up, if you're a third party and selling power to another client, you require a generation license, which takes quite a bit of time from EPRA, and there's quite a bit of, it's very bureaucratic. You have a lot of documentation required. It can take up to 3 months to 6 months just getting a generation license before you can actually start billing the clients. So that is why the uptake of solar has been pretty slow in Kenya, but obviously it has been on the rise recently because of the number of companies that have set up. So I definitely feel like if that is something that is worked towards, then we're going to see a lot of uptake of solar, because then developers are able to get acquire generation license pretty easily. Um, Another problem is what EPCs and many end user clients face is, of course, the lack of availability of funds. I feel like, and also there's a lot of, there is no local currency funds available for solar projects, which is extremely frustrating. Because even as a developer, you get asked a lot of questions like, if you can have your PPAs based in Kenya shillings, but unfortunately, many companies do not provide PPAs based in the local currency, because all of the funds that have set up here are, US dollar based funds or euro based funds. So you have to essentially borrow in dollars or in euros. So then the risk becomes too high for you to, sell to clients in Kenya shillings, but you're borrowing in dollars. The currency risk becomes far too high, and especially right now, because the dollar has gone through the roof due to various reasons like the war and inflation and other things. But the dollar has really it's at an all-time high. So a huge challenge is availability of funds, because there are many companies, many industries who want to go solar, but the reason SMEs can't really shift to solar is, because local banks also don't support solar as much, because they don't understand the technology yet. But I feel like in the next 2 to 3 years, we're definitely moving past that, where we've seen a lot of companies, a lot of local banks such as Standard Chartered, INM, and other local banks that have really been trying to push solar and support solar EPC companies, and so therefore I definitely see that Kenya is on the right track in that regard. So yeah, and then lastly, obviously competition. I feel like Kenya is a very price sensitive market, where every unit of power counts, every shilling counts. So and because like my panelists over here, they're pretty much the same as what I do. So there is a lot of competition, a lot of people who have set up. So a lot of international companies, a lot of local companies as well. So it's a very price sensitive market, and the prices of the modules and the inverters, they have been on the decline, but the margins in this industry have been fairly low for businesses to sustain themselves. So yeah, those are the top challenges I see in this space.
Definitely, these are very important points, and the professionals in Kenya, they have to become better and compete and learn how to have more technologies integrated into the sector, so they can stay competitive and
Yeah.
develop more projects. I have one more question regarding the technology. Speaking, how is the technology affecting the project performance, and what are the expectations for the project from the system or and the original equipment manufacturers and the service providers? Can you tell us a little bit about that?
Yeah, so technology, definitely technology has a huge role to play in terms of the performance of the systems. But I feel like over here, the uptake of this of newer technology solar panels has been really good. Basically, since if you see the last 5 years, you've had panels that are only about 390 watts per panel, but now you've gone with Jinko. As you can see, you can go up to 650, 660 watt per panel. So I feel like because for many of these clients, roof space is a constraint. So EPC and service providers are expected to utilize the roof to maximum capability, because you basically have a lot of industries that have set up here that have huge power demands, but their roof space isn't that great. So I feel like it's up to the EPCs to be able to maximize their roof space in terms of using the latest panel technology. And therefore, be able to give the best performance of the system. Then I feel like the OEMs, they do offer good, we have Jinko, for example, giving us 20-year performance warranties, and inverter warranties go up to 10 years. So I feel like um, uh, that is also what is expected from the EPC providers as well over here in Kenya, where they want a seamless process for getting warranties, or if anything goes wrong, we have the local companies like, for example, Jinko, and many of the inverter companies have set up here. So they look for a more seamless process if anything goes wrong. So yeah, I feel like those are some of the points and of how technology affects the performance of the system.
Thank you very much, Atharva, and I'm sure we'll come back to you with more questions.
Yeah.
Uh, are you with us? Justice, can you hear me?
Yes, I can hear you, Samir.
Excellent, excellent, excellent.
I hope you can hear me
Uh,
as well.
yes,
Yep.
I can. Mr. Justice has graduated from the Jomo Kenyatta University of Agriculture and Technology with a BS degree in mechatronics engineering in 2015. He has 6 years experience in technical sales, in particular to renewable energy. 1.5, 1.5 years is in domestic solar products and solar pumping. 2 years in EPC dealing with commercial and residential solar water heating and solar PV, and 2.5 years in solar PV project financing in commercial and industrial market for the Eastern Africa region. It's a pleasure, Justice. And if you like to talk more a little bit about your company and yourself, please go ahead. Over to you, Justice. Justice, you want to say a few more words about yourself
Thank you
and
so
the
much,
company?
Samir, for the
Yes,
brief introduction. And as you've heard, my name is Justin Leching.
yes, yeah. Okay, we'll start with the
Yeah,
questions.
that's what I'm doing, Samir. I hope you can hear me as well.
Yes, we can hear you. Continue.
Good. So, sorry, I can't hear you.
Okay,
Okay, thank you so much. I can first introduce myself. Is that fine?
okay.
Okay, thank you so much. Good. So my name is Justus Leching, and I work for a company called Ecoligo as a sales manager. And what we do as a company is that we offer finances for solar PV projects in the C&I market. And basically what we do is our core business is mainly financing and operation, and eventually become the project owner during the when the project is running. So what happens is that we've partnered with local EPCs, which in full is engineering, procurement, and construction companies, whom we subcontract them to build our projects. Then we provide the necessary finances for building the projects, starting from the technical design, from procuring, construction, and commissioning. Then once the system is up and running is when Equaligo takes up the equipment and runs the operation and maintenance of the equipment over the contract period. So we provide different types of contracts where we sign with our C&I clients between 3 years and 20 years. And if, for example, we sign a 10-year contract with the client, at the end of 10 years, we transfer the equipment to the client. So basically, that's a brief about our company.
Amazing, amazing. Thank you very much, Justice. Um, I have few questions for you. Maybe can you can tell us about the rooftop solar financing? What are the financing models available from ESCOs or international financing corporations and local banks? Can you hear me, Justice?
Okay, thank you for that question, Samir. We have different. Yes, I can hear you clearly. Yep, I can hear you. We have different types of financing models that we offer as a company, which is also being offered by other financials that are available in the market. The first one is PPA, which in full is power purchase agreement in terms of the kilowatt hour, either generated by the solar equipment or consumed by the clients. So, for example, if the client decides to go for consumption based, which mainly depends on their load profile, it might end up being expensive unless their load profile is like 100% utilization. So under this power purchase agreement, we have different types of these PPAs. We have one, which is a fixed money per kilowatt hour for whichever contract period. And it comes with either an annual escalation rate or a 0% escalation rate. So this one has nothing to do with the price the client is getting from the local grid supplier, that is Kenya Power here in Kenya. The second type of PPA is the variable PPA. This type of PPA is fully dependent on the local grid supplier price, that is Kenya Power. So what happens in this particular type of PPA is we offer percentage discount pegged on KPLC price. So, for example, if you are signing a 20-year contract with client A, we can give, say, 30% discount as the variable PPA. So what happens is that if the if the Kenya power prices goes up, our price will also go up, maintaining that 30%. If it also goes down, we also go down, but maintaining that 30%. But in addition to this, we also come up with a floor price to caution Equaligo or any project developer, as well as a ceiling price to also caution the client. This is because as a company, as a project developer, you've invested some amount of money on this project. And if the local grid supplier decides to reduce their prices much lower, then it affects your margins and your returns. So we caution ourselves by introducing that floor price, in such a way that we can't go below that floor price. At the same time, we put a ceiling price so that we also caution the client in the case whereby the local grid supply decides to increase their power prices, so that we don't charge them more than we are supposed to charge them. Number two on the financial models is the lease agreement. We basically call it lease to own. And how it's structured is that we offer a fixed price per month for a period of time between 3 years and 20 years. Of course, the longer the period, the less the monthly lease price. And the shorter the contract period, the more the monthly lease price. Again, this one also come either with the annual escalation rate or a 0% escalation rate, depending on what really the client in the C&I market needs. We have standard terms for all these two types of financial models. The first one is that in addition to this, we normally offer early purchase option, whereby if a client decides to go with a 20-year contract, for example, and maybe at year 5, he or she gets some liquidity, we give a predetermined value at the beginning during the contract signature in such a way that in between the contract period, they decide to take full ownership, they pay that amount of money and transfer the equipment so that they can take full ownership of them. Another thing is that at the end of the contract period, the client takes full ownership of the equipment. We don't offer a contract whereby at the end of the contract period we either renew or we take back the equipment. So for our case, they take full ownership of the equipment at the end of the contract period without further payment to our company. Another thing is that Ecoligo takes responsibility of the insurance of the equipment as well as operation and management of the equipment during the contract period. So during the contract tenure will not come and request the clients to make payment for operation or maintenance or insurance of the solar equipment. Last but not least is that we also offer guarantees, that is performance guarantee, which ranges between 80% to 90% depending on the financial model. 90% for lease and most probably 80% for the PPS, in such a way that if we don't meet that minimum guaranteed or warranted production, we compensate the client in the CNI market. And finally, we don't request for any form of collateral security for us to invest on these projects. What we do as a company is we perform some form of financial due diligence on the clients to make sure that they have the ability to make the monthly payment to the project developer. So we don't request any form of security in terms of title. In addition to this, we also have bank loans, which I would say we are competing, but don't really do what we actually do. So what happens is that some clients might decide to secure loans from their banks and use the money to fund these solar projects. But for this case, the bank has no technical liability for the system. They just give the client the amount of money they need. Uh, the client might give them any form of collateral security for them to secure that loan. Then the client will decide on the type of EPC they use. But for us, we have only specific types of EPC partners that we use. One other thing is that the bank, of course, will not issue any form of guarantee on terms of the system performance. And of course, the client will be fully responsible for the system implementation, operation, as well as maintenance of the equipment. And finally, there is also another form of financial model that is available, which is called shared savings contract. This was mainly suitable for the energy efficient systems and solar water heating. But as a company, as a financial, we don't offer this at this point of time. We have other companies offering this. And what this entails is that the financial and the client will come into an agreement based on the projections of the savings the client is expected to get for a certain period of time. They can maybe, for example, if they're proposing a particular system and maybe the system will give them savings of say 40%. So they have a discussion based on that 40% savings the client is going to get out of that project. So what happens is that they will sign a contract whereby some percentage of that savings will go to the financial, then the remaining percentage will be retained by the client. So that is another form of financial business model that is being offered, maybe not in Kenya, but in other countries. But as a company, we don't offer this particular type of financing model. That is it from my end, Maher.
Wow, very interesting, Mr. Justice. And uh, I just want to make sure that I understand this correctly. For the ESCO model, you are doing it for the energy efficiency and the solar water heaters, but you're not doing it for the PV. Is there a reason for that?
Uh, Sorry. So for shared savings, we used to only do for energy efficient systems and solar water heating.
Yes.
The reason we don't do it for PV is because of the contractual complications that came with it. It became very hard for us as project developers to explain this to our clients and have them understand. So we decided to fix ourselves into PPAs because PPA is straightforward. You can directly relate it with whatever they're having from their local grid supply, for example, Kenya Power in Kenya. So the shared savings became really complicated contractually and legally. So even as a company, we decided not to offer that shared savings contract again, even for the energy efficiency and solar water heating technology.
Okay, okay,
Yeah.
okay. Fair enough. Very interesting. Very interesting.
Yep.
One more question regarding the technology.
Yep.
Uh,
Sure.
how is technology affecting the project performance, and what are the expectation of project owners and service providers?
Yep. Thank you so much for this. Though my colleague Achava had already mentioned something, but I'll
Yes.
also have more on this. I'll first mention the first thing I can mention about this is about the modules that are currently available, and that is specifically the P type and N type modules technology. When you talk about degradation, the P type modules have a 2% degradation on year one and 0.55% for the coming years until the 25 years, which is the warranty period given by the manufacturer. So at the end of the warranty period, that is 25 years, the actual output will not be less than 84.8% of the normal power output. But when you talk about the N type, the degradation on year one is 1%, and then 0.5% for the coming years until 30 years, which is the warranty period. So the actual power output for the N type is 87%, it's 7.4% of the nominal power output compared to the 84% for the P type. So with the N-type technology, you get more output compared to P-type, which really makes sense in terms of savings and projected savings you're projecting to clients. Because for N-type, at 30 years, you'll get more than what you could get from another type of technology. In addition to this, there is also the guaranteed minimum production from the N type, which basically on average it's about 15% more than P type. Next, again, on this technology advancement is for ground mount systems. We have the tracking systems, which can be single axis tracking system, and we also have the normal fixed tilt system. So what happens with the tracking system is that they offer more production, rather yield, compared to the fixed tilt system. What happens is that the tracking systems maximizes on sun peak hours during the day. So at the end, if you have a comparison of the two technologies, that is the fixed tilt system and the tracking system will offer between 15 to 25% more efficiency than the fixed tilt system. But again, we have pros and cons for both in terms of space, because the tracking system will require more space. It might cost more money at the beginning, but it might be cheaper at long run. We also have the maintenance cost, which will be more for the tracking system. But if you try and compare the pros and cons of course, you'll come up into a solution whereby you might decide to go for a tracking system if and only if you have enough space. But of course, this is only applicable for ground mount systems. For roof mount, of course, the tracking system is not applicable for the roof mount systems. And thirdly, on the topic of technology, we also have the bifacial panels and the monofacial panels. Of course, the bifacial panels will have higher efficiency than the monofacial panels. They perform much better when they are mounted on a reflecting surfaces. And if you have them mounted on a reflective surfaces, the panels will capture sunlight both from below and above. That is from both sides. So at the end of the day, you increase the efficiency as well as the amount of energy that should be generated per panel. So you end up saving on space because you use one panel to generate more energy. Since maybe the same amount of energy you would have used two panels of monofacial, but you end up using one panel. So it saves on space and it's also cheaper at long run. Thank you. I hope I answered your question correctly.
Yes, you did. Thank you very much. Now I'm going to ask general questions to all three of you, and anybody wants to answer, I will start with the same sequence. So we'll hear from you regarding the current situation with the increase in international oil prices. What is the impact uh, of the increase in international oil prices on the solar PV market in Eastern Africa? Let's start with Julius. Julius, can you tell us what's happening on the ground in East Africa and Kenya with the increase in oil prices? Over to you.
Yeah, definitely it has had an impact, and especially in the logistics sector. The cost of shipping these items from overseas has gone over the roof. And I think it's difficult to go back to the client and try to pass on that cost. So you absorb that cost as well. And what the government here had tried to bring down the cost of power. But I think with the increase in oil prices, given that we do have some pickup plants which use oil, which are diesel generators, that has been impossible. And this in turn has made factories and industries turn to solar. So it's also a blessing in disguise, because now more people than before are looking to go solar due to the rising costs of diesels and rising cost of power from the grid operator.
Thank you very
Yeah.
much, Justice. All great answers. Artava,
Yes.
can you tell us about what's happening in the solar PV sector because of the fluctuation in international oil prices?
Yeah.
Over to you.
I mean, yes, just like Julius mentioned, it is kind of a blessing in disguise because now with the increase of oil prices, the cost of manufacturing has actually gone through the roof. And because of inflation, although the wages have increased, so the cost of manufacturing has really increased. If you have clients with steam boilers, which either run on HFO or diesel, the cost of that has increased. So that all of these, and because of the war, of course, there's so many other reasons the cost of manufacturing has increased. So a lot of companies are now looking at energy saving measures. Where solar comes, right into it, where the cost of power has always been pretty high in Kenya, but now it's again because the Kenya power rate is also based on the dollar rate. So if you see all these large IPPs, the independent power producers that have set up, all these PPAs are currently also in dollars. So they're buying power in dollars, so they have to pass on this cost. To the consumers, to the end users in dollars, and the dollar has gone through the roof as well. So that has meant that the cost of power has increased even more than what it was before. So like I said, before, our sales was we'd be approaching clients and going out and getting sales. But now what has happened is we have many companies coming to us because solar is becoming very widely known. And so I feel like this is the time where it's really accelerated the growth of solar. And which is also really good for the industry. It helps manufacturing industries cut costs. So I think it's definitely kind of a blessing in disguise. Yeah.
Uh, Thank you very much, Atharva, for this good insight. Justice, can you give us your insight regarding the impact of fluctuation in international oil prices on the solar PV sector.
Yep, thank you so much. I think we have pros and cons to this, specifically for us in the solar PV market, or rather, us as project developers. First is what, of course, Achava said, that the rising cost of oil has really affected the cost of production for this, for customers in the C&I market. And the increase in this cost, of course, will have an impact on their cash flow. So for them to reduce or some form of cost cutting, then they have to look at any other form of technology that is available for them to reduce their costs, which solar is one of them. But again, on the other hand, we have the issue of transportation and logistics, what my friend Julius mentioned, that has really also affected the cost of our solar equipment. So, with the rising cost of oil, that means the transportation cost will also increase. And, that cost is, of course, transferred to the equipment. And again, it also was supposed to have some impact on the energy cost the clients are getting from Kenya Power here in Kenya, because some parts, so that means if sell to consumers have to increase, but we didn't see that happen because in Kenya there was another different directive issued by the government to reduce power tariffs, and this came directly from the government to IPPs, and in fact the government injected some amount of money to caution the local grid supply against this. So we expected the oil price fluctuation to affect the kilowatt hour price the clients are getting from Kenya Power, but that one has not been achieved. Maybe in the next few months, maybe 1, 2, 3 months, maybe we'll see that really having an impact on the kilowatt hour price the clients are getting from their local grid supplier. That is it from my end.
Thank you very much, Justice. Excellent answers. My second general question to all of you would be about the operation and maintenance of the solar PV systems. You know, when you talk about PV, uh, it's not a small system that will last for a few years. It will last for 25 and now 30 years. So this is a long-term investment, and you need to maintain the energy and you need to maintain the quality. I know this is a very competitive market and the prices are very important, but the quality, I think it's much more important than the price because this is a long-term investment. So my question is to all of you is how do you maintain or what are the best practices for maintaining these systems to provide the energy yield that you want? We start with Julius. Go ahead, please. Over to you.
Okay. So we do once we install the solar system, we do offer a performance guarantee for 1 year. So we offer operation and maintenance of that system for 1 full year. After which, now, if the client is willing, we go into a contract whereby we bill them once a year, and then we track the system's performance and and ensure that it's operating at its optimum all the time. So the model we've adopted here is we provide monthly production reports to all our clients every month. For the first year, we send them monthly production reports. We also do have someone in the office tracking the system, which systems are online, which systems are offline, which systems the production appears to uh, go down, which might be an indication of a problem, maybe accumulation of dust or shading due to overgrown trees, and so on and so forth. So what we have been able to do over the years is establish that consistency of system operation, which has proven to be very important to us, because right now most of the businesses we get them through referrals, and our clients putting in a good word for us.
Excellent. This is the best way to do business. Word of mouth will
Yeah.
give you a great work. Atharva, we'd like to hear from you regarding the O&M best practices. Go ahead, please.
Yeah, so I mean, we do offer some of our clients with PPAs. So we have essentially, have long-term contracts with the clients, where our some of the contracts that we have go on from 15 to 20 years. But what we essentially do for our operations and maintenance is we have site managers, and then we do quarterly testing. So we do like IV curve testing, resistance testing, and all sorts of. We have quarterly reports for that. And then now, depending on where the site is, so for example, if it's what the site is in a very dusty or industrial location, or near a cement factory or something like that. We then have a full-time person there based at one of our sites where we've done this PPA. And so they are essentially, to clean the panels and to make sure that they're operating at, most efficiently. And the catch here is that whenever we do sign a PPA, it's in our best interest to make sure the plant is running as smoothly and operating without any glitches, because at the end of the day, our revenue is what's going to be affected. So it's in our best interest to always be doing these quarterly tests, doing consistent site visits. And so therefore we are able to give the clients and provide the clients with the best possible service, because again, if we don't maintain our systems, it's us that's going to lose out, whether it's in 3 years, 5 years, or after 15 years, if we don't maintain our system correctly. So yeah.
Thank you very much for this nice answer. Definitely, we have to focus on quality, and we have to focus on performance. Mr. Justice, can we hear from you? What are your best advice for the long-term performance, maintaining the
Yeah.
long-term performance of the solar PV plants?
Yep.
Over to you.
Yep, good. Thank you. So as I mentioned earlier, as a solar financial, you take ownership of the equipment during the contract period. It can be 20 years or 15 years, that longer period. And in line to that, we also issue this performance guarantee to our clients. And as a company, for you to get revenues, you need to meet the minimum warranted functionality that was signed with the client. So basically, we have our O&M services that we issue, and we have guidelines, to the O&M that needs to be done by our O&M partners, that is our technical partners. So we have guidelines, starting with the scheduled maintenance, whereby there's visual inspection of the components, the panels, as well as the inverters, as well as the cables. We have fixing of small defects, like for example, a cable has worn out, it needs to be fixed. We have cleaning of the panels, of course, because if we have dust on top of the panels, it really has a negative impact on the efficiency, and of course the vegetation management around the place whereby we have the solar installed. So basically, for scheduled maintenance, this is normally done in a frequency annually, depending on the system size. For example, any system size more than 200 kilowatt peak, we do it like 4 times a year. System size less than 200, we can decide to do this scheduled maintenance, say 2 times a year. In addition to scheduled maintenance, of course, we have the unscheduled maintenance, which you can't predict. These are the unpredictable and scheduled maintenance. And for this, we also have guideline to our O&M manager and procedure for doing this unscheduled maintenance. In addition to this, again, we also have the monitoring, which as a company, we have a common monitoring platform whereby we monitor all our platforms. And we've given access to our customers as well as ourselves. You already have access to this, and we access them real time and anytime in such a way that if you're somewhere in Europe and the project is in East Africa, and you can see that the system is not performing as required, then of course you reach out to your O&M partner and ask them to visit the site and check what the problem is, so that we have a seamless, we have a continuous generation of power. And at the end of the day, we are able to meet whatever we guarantee the client. So for these solar PV systems, for scheduled maintenance, we have different guidelines, as I mentioned, which has to be followed. And each and every time the O&M manager or the O&M partner visits the site, they have to share reports to our technical manager as well as our asset manager. So as a company, we have an asset manager who is in charge of all projects under operation. So with this, we make sure that anything pertaining performance of the solar equipment is as expected and as promised to the client. So we avoid a situation whereby we end up installing a system whereby it doesn't benefit a client in any way. Thank you.
Excellent. Thank you very much, Justice. Um, my next question is about the regulations. What do you like to see as development in regulations to take the solar PV market to the next step in Eastern Africa and Kenya in particular? uh, and we can follow the same sequence. Julius, would you like to tell us from your perspective what is required as regulation development to take the solar PV sector to the next level in Eastern Africa? Over to you, Julius.
Thank you very much. I think for us to go to the next level, we need this bill on net metering passed. I think that will revolutionize solar, because either way, whether you are consuming or not, you will be savings. You will be making savings, and I think we need all the operators in this industry to lobby and in all the agencies that are responsible for this, so that we can see this bill passed. Of course, I don't think it's going to be passed anytime this year due to the elections. We are in an electioneering period. But in the coming years, I think it's something that we should really focus on. One issue we've been having is that solar systems are exempted from taxation and duties. But what we've experienced is that that is just on paper. When you ship in items, the taxman tries to separate the components and tells you it's only the solar panels, not the mounting structures. So the mounting structures, you'll have to pay duties for them. So I think that's an area that we also need to look at, because eventually if we pay duties, we pass on this to the client, which still makes the systems as expensive as well.
Oh, very interesting. Very interesting. Thank you very much, Julius. Mr. Atharva, what do you think is required development and regulations to take the solar PV market to the next level?
Yeah, so I think definitely net metering, like Julius said, and like I mentioned before, net metering is going to be an absolute game changer for here in Kenya, where we completely decentralize the power, and then we have many commercial and industrial clients setting up their own power plants for self-consumption, as well as for the grid, and they will be, like Julius mentioned, getting savings regardless of the consumption. And then that will also mean that you essentially don't even require batteries as of yet, because basically you can supply to the grid during the day, and then at nighttime you can use some of those credits for the night consumption. So that is going to be a huge advantage. But I also think that subsidies for the mini grids and the microgrid sector, because yes, we are mainly focusing on the commercial and industrial sector and the private sector, where all essentially the money is, but we need to also focus on the long-term goal, which is electrifying the whole of Kenya, where we still have 40% of the people who don't have access to power, and the only way we can we can do this is through mini grids and microgrids, and setting up of those. So if there is certain regulations, certain easing of regulations for setting up foreign companies for mini grids and microgrids will definitely take us a long way in electrifying the whole of Kenya. So yeah, those are the 2 points for me.
Appreciate it. Thank you very much. Yes, I agree with you. The mini grids and macro grids are important, but the safety issue is also very important for the TSO, the transmission system operator, and so giving away this is a responsibility is not very easy, and so maybe the development of many grids can be also integrated under the TSO. Doesn't have to be a private party operating it, but the safety is very important for the grid operator. Thank you very much, Mr. Atharva. Justice, we like to hear from you regarding what, in your perspective, what are the regulations required to be developed in East Africa and Kenya in particular to take the solar PV sector for the next step, next level? Justice, can you hear us? Okay. Maybe I can ask another question to Julius regarding the required capacity building in the market. What do you think is required for capacity building in the market to enable the professionals and technicians in serving the solar PV sector? Over to you, Julius.
Did you ask about capacity building?
Yes, please.
Oh, yeah, sure. I think the international companies that are selling components here, such as the inverters, the solar modules, they should open training centers here and train local technicians on how to maybe rectify and assemble some of the items that they ship in here. Because I remember a few years back, we had a problem with an inverter, and it had to be shipped all the way to South Africa, and they ship a new one, which was quite hectic and expensive as well, because an inverter is something like 100 kilograms. So nowadays, we've seen some companies like Huawei setting centers here, whereby they are locally available, and the turnaround of rectifying or replacing a component, it's quick, which reduces the losses incurred due to downtime or damaged components. So I think it's good that those international companies can be encouraged to train locals here and equip them uh, to operate and service their components.
Yeah, thank you, Julius, very much. Thank you. Atarva, what is your recommendation for capacity building development to take the solar PV sector to the next level?
Yes, so I certainly think so far we need a lot of engagement with universities. So one of the initiatives at Strathmore Energy Center Strathmore is one of the universities here in Kenya, and they have a great initiative for local technicians and local engineers to be certified and have training courses. So just like that, it would be very interesting if, like Julius mentioned, if there could be international companies reaching out to the younger people through the universities that are local, that are available here to really build capacity among the young engineers that are coming up today. Because nowadays there's a lot of passionate young engineers that Kenya is producing in the renewable energy space, and so there's definitely a lot of scope for that. So I think definitely we need to target the university, since it's gonna target the young people and the young engineers of tomorrow.
Thank you. Thank you very much, Atharva, for this insight. Justice, are you with us? Justice? No? Okay. Justice is having a little bit of technical difficulties. Well, Priyanshi, do you have questions from the audience you would like us to answer?
Yes, sir. We have two questions. I'll display it on the screen.
What is the largest size capacity of solar ground mounted PV project with storage and without storage currently functioning in Africa or in East Africa? Um, uh, Julius, you like to answer that, or Atharva?
I think the largest solar plant we have is Garissa, 55 megawatts, which
55.
is yes.
Okay.
We currently don't have battery storage utility scale, but we do know of some factories who have installed energy storage solutions in the range of megawatt hours.
Okay, perfect. Thank you very much. Priyanshi, we answered the first question. Now the
Yeah,
second question.
I believe Mr. Atharva wants to add something on the same.
Yeah,
Oh
sorry.
no, I think yeah, in Kenya, I think Julius has summed it up pretty well. Not many energy storage plants are set up here, but I think the largest energy storage one is, I think it's about 2 megawatt hours of storage for a tea factory here in Kenya. But then I don't know, it was done quite some time ago, and the project was not as successful, and they had quite a bit of problems with that project, I was told. So, but yeah, in Kenya we don't have a utility scale storage solution as of yet.
Thank you.
So we'll move on to the next question. This is the last one.
Okay. The performance guarantee is based on generation or performance ratio. Um, Atharva, you like to answer that question?
Yeah, sure. So mainly as lean energy, we do give performance guarantee on the generation. We have an irradiation sensor that is that comes along with our monitoring system, and so we're able to see how much power with the irradiation sensor, how much power the plant is supposed to generate versus how much it actually generates, and that is what and then that is the performance ratio. So we're pretty flexible. It depends on what the client wants. If the client wants a performance ratio, a guarantee based on the performance ratio, we can offer them that. If the client, but generally our PPAs are structured for guarantee on the generation. Yeah, Julius, maybe you wanna add.
Yes, please. Julius?
Uh, I think for us, we do base the guarantee on the performance of the generation of the solar system, because most of our systems are straight up sale. So we do guarantee our clients a certain percentage of power generation based on the system size.
Okay, so you have a smart answer. You know what the system can generate, and you give them a minimum generation performance guarantee.
Yes.
Very good, very good. Justice, are you back with us? Can you hear us?
Yes, I'm back. I hope you can hear me.
Yes, we can. You like to
Yep.
answer the question?
Yep.
Go ahead.
Yep. The question on the minimum guarantee, what we do as a project developer is that we normally request our EPC partners to provide a PV simulation report, you know, as part of the technical due diligence just before the project implementation. So from the final PVCs report that we get from the EPC partner, we pick the P90 value, because from the PVC's report you get different values. You can get the P90, P95, or P70. So we need to be very conservative. So we pick the P90 value, which I would say is lower than the P70 value. So out of that P90 value, that we put as the expected annual generation. So for us to issue the minimum guarantee, we normally give 80% to 90% of that P90 value. So that's how we arrive at the guaranteed value. I hope I answered your question.
Yes, yes, you did. Excellent.
Thank you.
But you know, the PBSist report is has a lot of information in it, and there is a lot of ratios that you have to make sure they are correct before you know just accepting the report. So there is a lot of technical information in the PVSist report that you need to make sure that whoever prepared the report has prepared it correctly.
Yep, sure.
Yes.
So Samira,
Yes.
that's why as a company we only use qualified EPC partners, and before we have them as a EPC partners, there are different documentation that they normally share with us, including reference projects as well as technical documentations for those reference projects, as well as performance reporting for their reference projects. From that you're able to know how technical or how expert, you know, how expert how their expertise is in the solar PV industry. So from with whichever report we get from these CPC partners, we trust them. And again, even before they issue the report, they have to give us the site visit report and give details of the site information. For example, the roof, the way the roof is has an effect on the PVSS report. So there are quite a number of information about the site conditions, the locations that they have to share with us before they even share the site, the PVCs report. So by the time we are getting the PVCs report, and that is the final PVCs report, you already have almost 100% understanding of the site. So we'll get very minimal errors in the PVC's report. And again, as I mentioned, we use a conservative value, which is P90. And the P90 value is less than the P70, the P50 value that you can get from the PVC's report. So we use a conservative value as well to protect ourselves as a project developer.
Yes.
And in
Uh,
addition, and in addition to that percentage of 80%, then we are good to go.
yes. Thank you very much. Priyanshi, do you have more questions, or I should go back and ask our dear Julius the questions about the regulations and capacity building?
So we don't have any more questions.
Okay,
That's all. Yeah.
okay. So I'll go back and ask Julius uh, the questions about the justice. Do we have a question about what
Actually, sir,
regulations?
I would request you to wrap up because we are running short of time. We just have 5 minutes left.
Yes, 100%. 5 minutes, we will wrap up.
Sure, sir.
Uh, Thank you. Justice, if you
Yes.
can hear me, please. In your perspective, what are the regulations required to be developed to take the solar PV sector to the next stage?
Good. Thank you. That was the question that you asked just before I dropped off.
Yes.
In addition to the net metering policy and the VAT exemption policy that were both mentioned by my colleagues Achava and Julius, some few years ago, Samir, I was working for a solar water heating company. And during that time, the government of Kenya had issued a regulation in terms of solar water heating system installations that for any household consuming more than 100 liters per day, it is mandatory for them to install solar water heaters. And when that regulation was being discussed by the parliament and just about to be passed, many people in Kenya started installing solar water heaters in their households, in their residential apartments. And then the solar water heating business boomed. And many people made money. They made income out of the solar water heating business because of that policy that was issued by the Parliament of Kenya. What I think on the same thing, I think the government should also issue a policy in terms of the energy consumption that any business consuming a certain amount of kilowatt hours per day or per month have to install a solar. And if that is done, then the solar PV industry in Kenya will really grow. That is my take. Thank you.
Thank you very much. Um, I, I agree with you with one condition.
Yep.
Before you do install solar PV, before you install the solar renewable or any kind of renewable energy, you have to finish your energy efficiency measures. So for facilities, you need to do the energy audit, complete
Of course.
the energy audit, energy conservation measures, and then install the solar PV. Yes, I fully agree with you. But I have a question, with a follow-up question on the solar water heater. How did you enforce it? How did you implement it? You can issue the regulation, but implementing the regulation is another story. How do you enforce it?
When a policy is passed in parliament, then it becomes a law. So if you don't follow the law, then what happens? You are jailed. So you had to go out there and propose the solar water heating solution to clients. And also the good thing is that EPRA, that is the Energy Regulatory Authority, was sharing this information to the public. So the public, these private developers were aware of that policy. So they had to implement by installing the solar water heaters. If they were not going to do that, then that means they were going to be penalized,
Okay.
or their license revoked. So it
Yeah, they
became
had
public.
fines as well. So yeah.
Yeah. So it became public information. People knew that there was a policy, and people had to install solar water heaters in their residences.
Fantastic. now we are close to 1 minute before closing. I'd like to thank each one of you panelists for your cooperation and fantastic answers. I'm sure that it will help all the listeners in moving forward in the East Africa market and becoming more reliable, more using more clean energy, especially solar PV. Thank you, Priyanshi, for your kind support, and thank you, Solar Quarter. Over to you, Priyanshi, and big thanks to Jinko also.
Thank you so much, all our esteemed panelists, for this wonderful session, and very special thanks to Samir sir for superbly managing the session. So, with this, we come to end of our virtual event. Thank you everyone for extending your time and support for this event. Special thanks to our partner Jinko Solar for extending their immense support to organize this event. We promise you to come back with more exciting topics very soon. So the floor is open for networking. Thank you. Till then, bye from our end and take care.
Thank you.
Bye
Thank you.
bye.
Bye.